Hi, welcome to lawschooly.com. Today we're looking at LSAT Preptest 64, Game 1. This is a pretty easy game, and I think it's a good one if you're trying to sort of make some breakthroughs with doing more work in your head and maybe less on paper. This is certainly a good game to kind of try those skills out and see what you can do mentally. And then if you don't do that on your first go round, certainly on the review, try to do some work moving variables around in your head to confirm or get rid of answer choices. And we'll talk about where maybe that work would be best done throughout the game. Okay, let's take a look at the setup. Okay, so for setup, this is a basic ordering game. Like many game ones in a section, it's pretty easy. So again, these games are typically where you just sort of warm up your brain and you want to knock them down quickly. So don't view them as a leisurely warm-up, but they are a warm-up where you try to score some extra time that can be applied to harder games that you're going to face later on in this section. Yeah, and I can't think of any exception to that. Generally, the first game is going to be something that you can do in under 8 minutes, ideally, often well under 8 minutes. And this game's no exception. Okay, so for the setup, we've got a basic ordering setup again, 6 spaces, which are these 6 parking spaces. So I'm treating it as a linear game, and that's definitely the correct thing to do here. I'm treating it as an ordering game. So I've got my spaces 1 through 6, and then here are the employees that will be parking in them. Exactly 1 employee per spot, 6 employees. So for rules, we've got Y must be in a higher numbered spot than T. So write T, then Y, sort of the classic ordering rule diagramming style here. And then X must be in a higher numbered spot than S. So S, X. And then Robertson must be a higher numbered spot than Y. And here, you're always supposed to link up rules. You can just make sure that that goes right on, tack it onto your first rule. So you only have one thing to look at, this nice chain here. And then our final rule is that R must be assigned to spots 1, 2, 3, or else 4. And I think this is something where they're kind of hoping to throw you off your game mentally. You should recognize right away that there's no way that R can be in spots 1 or 2 because T and Y have to go in there before R. So the earliest you could have R is 3, and then because of this last rule, we could also have R in 4. Now, when I see 2 possibilities like that, and there's not a whole lot of rules, it's good to kind of just draw those possibilities in. So you could draw it off in a separate diagram over here, or you could just, I think it's simple enough here to just write our 2 possibilities. We could have T, I, and Y, T, Y, and R, sorry, and then we could have, T and Y somewhere in these 3 spots, and then R in 4. So if that's confusing to you, feel free to write it off separately on the side. But this just says that T and Y are somewhere in these spots, in these first 3 spots, and they're in this order. And then here it's fixed. We've got T, Y, and R. So this is my main diagram, and with that, I'm really ready to just go to the questions. Question 1 is the acceptability question. Just take your rules one at a time and eliminate answer choices where they're violated. Nothing tricky here. You're left with E is the correct answer on this one. So move on to question 2. Okay, question 2 gives us an extra condition, which is that T is assigned to a higher spot than S. So you'd have S, X, and if you want to rewrite it, then you could put this whole T, Y, R chain after that. And now this means that 3 things, S, T, and Y, all have to be before R. So that puts us definitively in our first scenario up here where r is in 4. We can label these if we want to help keep track of the fact that they're different scenarios. So we know r's here, and then before it is s, t, y. And that should be very, very quick work to do. There's our last spot. So once you have that, it should be very easy to solve the question from there, and we just look at what could be true given this scenario. A, Young is assigned to spot 2. No, that's not possible, so A is gone. B, Vaughn is assigned to spot 5. Vaughn's a free variable. We don't know really much about what's going on with Vaughn ever. And so why couldn't he be in spot 5? That should be totally fine. You just put X there, and that works. That could be true. So B is the correct answer. Okay, that does it for question 2. Question 3 is the kind of question that I think that fast test takers are getting some real bonus time by just doing this work in your head. So we're asked which placement of one of these guys can fully determine the rest of the order. So you know, you could do it all out with trial and error and do like the scenarios that way, or if you can do it in your head, I think you're going to save a little bit of time. So maybe if you didn't do it in your head on your first work through, see if you can visualize this. So we need to find, again, a placement of one of these guys that fully determines the placement of each of the other ones. And A is S in spot 1. That should not strike you as a likely answer at all, because, you know, at the very least, you've got V and X flying around. You don't know, you know that you're in this STYR rule, but hopefully you can see in your head that V and X can still flip positions back here. So you can have X, then V, or V and X. So that eliminates A. And again, you know, I think there's bonus points to come from just doing that in your head speed-wise. And then we look at B. Young is assigned to space 2. Young being assigned to space 2, it hardly tells us anything. You know, you could have T here, obviously, but then we don't know if R is here or if R is in this 4 spot. So that's immediately uncertainty, and it doesn't fully determine things. So B's gone. C. Vaughn is assigned to space 3. Let's see. That looks a little more promising because Vaughn is our free variable. You know, he has no restrictions. So at least if we know where Vaughn goes, it might make some sense that it'll fully determine the order. Because now we see we're stuck with this TYR, and then what's left? Just S and X, and they have to be in order. So that gives us C as the correct answer. So, yeah. Again, quick work even if you're doing it trial and error and writing it out, but maybe just as mental practice. See if you can see which ones are incorrect in your head as far as A and B go, you know, and that will be some good mental practice for you. 4 is the only sort of moderate difficulty question in the game, and it's one of these questions where you've kind of got to just do a bunch of mental work here. We're asked how many of the 6 employees are limited to just 2 spots. Well, so let's count them off. You know, we know R is, because we've got that right in our main diagram. The slightly trickier thing is seeing that T and Y are also limited to just 2 spots. See, here, T and Y are stuck in 1 and 2, and up in this scenario 1 situation, well, T is still stuck in spot 1 and 2. You know, let's draw that out quickly. If R is in 4, well, T is still stuck here or here, because if you put him here, there's no room for Y. And similarly, Y is stuck here and here, because otherwise, if he's here, there's no room for T. So that's then, you know, T and Y that you can add to this list. And you know, that's a really common pattern with T and Y there. 2 variables into 3 spots. If they're ordered, you know, they're each stuck in just 2 spots. They can move around a little, but they have to retain their order. And so then, at this point, I thought, okay, maybe these 3 are it, but to be careful, I'm obviously looking if there's any other variables that are stuck in just 2 spots, and the likely candidate to me seemed to be X. Even in this scenario where R is in the 4 spot, you can't get X into any of these first 3 spots because S has to be before it, right? And then suddenly there's no room for both the T and the Y. You can't jam them in one spot. So that always forces X into these back 2 spots. It's got to be in one of those. So, if you were annotating that out fully, you'd write it like this. And yeah, so that gives us a 4th variable, X, and then the answer is D. 4 of these things are limited to 2 spots. So, tricky question. Again, you're going to have a major bonus if you can sort of do this work quickly, possibly in your head, seeing right away that T and Y are limited to just 2 spots. Question 5 gives us the new rule that Young is assigned to a higher spot than Sousa. So you'd draw a little extra arrow here, implying that S has to be before that Y. So you want to rewrite that T, Y, R, and then S, and then X. Okay, and that'll help you remember that that's just true for this game. So then with this new rule, things are pretty limited because R is stuck in 4, since now 3 variables all have to be before R, and then you'd have Y stuck here, and then T and S can switch positions in this first spot. So the game is pretty well determined from this point. So now with this diagram, what can be true? That's what we have to figure out here. T is first. Is that possible? That's answer choice A. And yeah, T is first. You do T, S, Y, R. That's very possible. Then you could have V and X, or X and V. Yeah, so A, T in first could be true. That's the correct answer. The last problem, problem 6, is basically a gimme. I'm kind of surprised that they put this in here, but it just asks us, and sorry my diagram's getting a little crowded up here, but it just says if R is in 3, which of the following must be true? Well, if R is in 3, we know we're in that number 2 scenario here that we discussed, and that means T and Y are here. And then first, before you do any additional work, because stuff's floating around back here, you don't really know where it is, see if this inference answers the question. And if you scan, it does. Down in E, you see that Young must be assigned to parking space 2, just like in our diagram, and that's the correct answer. So that's a real gimme question for people who set up the main diagram correctly and saw that there's these limited possibilities, 1 and 2 here. That's going to be really easy. So, so that finishes the game. Very easy game. I would expect, fast test takers might be doing this in 6 minutes, even less, maybe 5.5 if they're really fast, But don't put too much pressure on yourself. But be aware that this is the kind of game that you do want to be doing faster than you do an average game. If you're taking 8.5 minutes, perhaps you can practice speeding up. So keep that in mind. Okay, thanks a lot. Let's move on to game 2.